Now, 2 does not go well into 7, so when that happens, use lowest common multiples. We do the same thing with 2 and 3, with 5 and 2, with 3 and 7. Anytime you have one not going into the other, we use the lowest common multiple, and the lowest common multiple of 2 and 7 is what?
14.
14. So you can have a positive 14 side and a negative 14 side, and your result is Mn2S7. This is manganese 7 sulfide, Mn2S7. Okay. How are we doing with this stuff? Give me a thumbs up if you're comfortable and a thumbs down if you want to go over it again. Okay, let's go over it again. Okay, so when we're working with the name to the formula, when you're working with the name to the formula, you have to remember the entire compound is going to be equal to 0. So you use what you have and then balance them out. So let's just throw one up here. How about something that would be 5? Nickel. So let's say we have nickel 5, and then what's something that would be just 2? Sulfide. There we go. Nickel 5 sulfide. Cool? Now we know that nickel is Ni, so we'd write Ni. And we know sulfur is S. Sulfide is S. And it tells us the nickel is +5. And the sulfur is -2. Okay, does that make sense? So you have to realize, well, 2 doesn't go well into 5, so we're going to use a lowest common multiple. Lowest common multiple of 5 and 2 is 10. Which means this side is going to have to be +10, and this side is going to have to be -10. How do you make this side +10? Ni2. How do you make this side -10? Add 5. And our chemical would be Ni2S5. Oh, okay. Are we cool? All right. Thumbs up, we're good? Thumbs down if you want to go over it again? All right, moving on. So, level 4 complete. Ready for level 5? Just 5.
Let's go.
All right. You saw these things earlier, but I want to talk about them. Polyatomic ion. Oh, this is important. Really important. Going back before we talk about polyatomic ions. Write this down. Don't put charges in formulas. No charges in formulas. No.
Who would do that?
If I didn't tell you, probably about a third of you. Don't put charges in the formulas. The charges are your work. Your formulas are your final answers. Okay? I don't want to see +5s and -2s in my Ni2S5. My final answer is Ni2S5. It is not Ni +5 2 S -2 5. Don't do that. Because every year somebody does. Then I have to laugh at them. And I don't like making them uncomfortable. So no charges in the formulas.
Never.
Never ever. Okay, last thing, polyatomic ions. There are about 100 polyatomic ions. We're only going to learn about 95 of them.
Yay.
I'm joking, we're only learning 7. So we're going to learn just the 7 most common polyatomics. If you want to learn more, you're welcome to take chemistry AP. I think then we learn like 15. But we're just going to learn the 7 most common. A polyatomic is a bunch of atoms that move as a single block. There's a bunch of atoms and they move as a single block through the reaction. The simplest one, the one we use quite often, is nitrate. NO3 is nitrate. It has a -1 charge. Now I told you yesterday at the beginning of class, everything in this class, all the chemicals we're using are what?
Not that.
Binary, yeah. Everything we use in this class is binary. One positive thing, one negative thing. So let me show you a good example of a chemical of nitrate, NaNO3. Now, if you try to read this as sodium nitrogen oxide, you've said 3 things. And you're wrong, okay? Everything we're going to do is binary. Sodium nitrate, sodium nitrate. Sodium's positive, nitrate's negative. It's binary, one positive thing, one negative thing.
So I use potassium nitrate to make like little sugar rockets.
Correct. Yep. Potassium nitrate.
So that would be
Next, hydroxide. Hydroxide is OH and it's got a -1 charge. Hydroxide is OH, has a -1 charge. The other -1 is clearly a polyatomic, and it's called acetate. C2H3O2 is acetate, and it also has a -1 charge. Acetate. Acetate. Do your homework. Don't be an acetate. Listen to your parents. Don't be an acetate. Okay, now I wish it would be great if all the polyatomics were -1, but they're not. This is a common one, sulfate, SO4 2-. Sulfate is SO4 2-. Yes?
So what if it's just like just the sulfate, there's nothing else with it?
Then it would be an ion and you couldn't hold it. Anything you can hold, anything you can see, anything you can smell is going to have an oxidation of 0. It's going to be something sulfate.
Okay, so are we ever going to come across like the nitrate like that just by itself?
No. It'll always be an anion in a compound.
what do you use sodium nitrate for?
Sodium nitrate? Mostly just for when I need a quick sodium ion. Like when we were doing the flame test, spraying the sodium in. Every teenager's favorite polyatomic is carbonate.
Yes. Why?
Because if you get some hydrogen carbonate, it makes fizzy drinks at In-N-Out Burger.
Dude,
Or your carbonated milk, exactly. Or your carbonated milk.
I love my milk.
You can try carbonated milk next spring when we carbonate sodas. When we do solutions, I'll break out the dry ice and we're going to make soda, so you can make carbonated milk.
I have this soda stream.
Yeah, like SodaStream.
I got one too. We just all bring them in.
Have it, yeah, like we'll make like carbonated chicken soup and
We'll have a soda off. Who makes the best soda?
carbonated V8. Phosphate is PO4 3-. Phosphate is PO4 3-. There's no standard. It could be PO4 -3 or PO4 3-. There's no standard. Okay, so these are the 6 negative polyatomics that we're learning, and we're going to learn one positive polyatomic, and that is ammonium. Ammonium is NH4, and it has a +1 charge. And these are the 7 polyatomics we're going to learn. Okay, just 7. There are hundreds. You are welcome to learn all the ones you want on your own, or take chemistry AP. I think they make you learn a few more. But for the most part, this suits us pretty well. Now, some of you have already seen the pattern. It's kind of interesting when you look at nitrate, acetate, sulfate, carbonate, and phosphate. What's the pattern?
8.
Yeah, the 8 means what in the ion?
Why is 6 afraid of 7?
Because 7, 8, 9.
What do you see that's common in nitrate, acetate, sulfate, carbonate, and phosphate? Yes, and?
They're green.
And they're green. No, there's something in the ion.
They're all negative.
Yeah, there's oxygen. Now, you go nitrate, acetate, sulfate, carbonate, and phosphate are all something with oxygen. Now, later on, as in like either in chemistry AP or in college chemistry, you'll learn quite a bit more about that pattern. But right now, you might just realize that, oh, nitrate is nitrogen and oxygen. Sulfate is sulfur and oxygen. I bet if I asked you to draw bromate, you could give me a pretty good guess what it would be. Or if I asked you for chlorate, you could probably give me a pretty good guess what it would be, because 8 means with oxygen. So if you find yourself writing a polyatomic with oxygen, make sure it ends 8. If you write something 8 that doesn't have oxygen, you did it wrong. Okay? And that's going to happen a lot. A lot of you are going to write 8s when you want ides. You're going to write nitrate when you want nitride. And you're going to write sulfate when you want sulfide. If you write an 8, make sure there's an oxygen in that polyatomic. Yeah?
How come hydroxide?
It's old. So it's got a strange name. Hydrate would make more sense, but a hydrate's something else. Okay, so what is this?
Copper.
Copper sulfate. Copper sulfate.
Yeah, if you said copper sulfate, you're almost right.
Copper.
Copper.
Copper tetrasulfate.
No. Remember, copper is, guys, can we focus, please? Copper is a D block metal, so what should it be?
It's copper 4. Copper
Getting warmer. Warmer. 2. Copper 2 sulfate. Again, the sulfate is negatively 2 charged. The sulfate's minus 2. That makes the copper plus 2. So we know this to be copper 2 sulfate. Can you see why it's copper 2 sulfate?
Yes.
Okay. Here's another one. What is this? Lithium nitrate. Lithium is in group 1. It doesn't need a Roman numeral. Lithium nitrate, and we're done. Why does it need a Roman numeral? It's in group 1. So lithium's always going to be plus 1. It can't be anything but plus 1.
Do you distribute the 2?
No, there is on.
But no, you don't need to like distribute. Just realize there are 2 NO3s.
Oh, okay.
Okay. Now would be a good time to talk about something you don't do with polyatomics. Polyatomics never get prefixes. Polyatomics never get prefixes. Despite what you see in the old vitamin bottle from, 100 years ago, prefixes do not show up with polyatomics. So what is this? Zinc. Nitrate is minus 1, so this is zinc. Right. Nitrate is minus 1, guys. Nitrate's minus 1. There are 2 nitrates in this chemical formula. That means there's a negative side of minus 2. The positive side has to be plus 2. This be zinc 2 nitrate. Okay? How are we doing? Okay, good until the last one? All right. So again, polyatomics, they don't get prefixes. They don't get prefixes. And if you ever name something three things, you did it wrong. So sulfate's minus 2. You do need to memorize the prefixes, or you do need to memorize the polyatomics. You just need to. Okay? You need to know that sulfate is SO4 with a 2 minus charge. You need to know carbonate is CO3 with a 2 minus charge. Okay? You just need to memorize those polyatomics. I'm only asking you to memorize 7 things. It's not like Spanish where you get 7 things every day. Okay, so nomenclature practice. If you wouldn't mind, please name these chemicals.